Imagine asking an AI to add authentication to your application, and within seconds, the feature appears across multiple files. Your routes are updated, your database logic is modified, and your API now returns authentication tokens. Tools like Cursor, Copilot, and Windsurf already do this today. But here's the strange part. The AI model itself actually has no idea what files exist in your project. It doesn't know your folder structure, it doesn't see your repository, and it certainly doesn't open files on your computer. So how does it know what code to change, where to change it, and how to integrate it into your project? Most people imagine the process is something simple. A developer writes a prompt, the code editor sends it to an AI model, the model generates code, and the editor inserts the result. From a bird's eye view, that explanation sounds reasonable, but the reality is far more complex. Modern AI coding tools are not just text editors connected to an AI model. Behind the scenes, an entire system is responsible for understanding your project, selecting relevant files, coordinating with the AI model, and safely modifying your codebase. In fact, two major systems are working together behind the scenes. The AI model, which generates the code, and the AI-powered IDE, which understands your project and orchestrates the entire process. When you zoom out, what appears to be a simple AI assistant is actually a full orchestration system retrieving code from your project, preparing context for the model, applying changes safely, and verifying that everything still works. And here's the key insight. The AI model, the part everyone talks about, is actually the simplest component of the entire system. The real complexity lies in everything built around it. At its core, the AI model is a large language model trained on massive amounts of programming data. And during training, it analyzes millions of code examples from open source repositories, documentation, tutorials, and developer discussions. By studying these examples, the model learns patterns in how code is written, how functions are structured, and how developers solve problems. But the model doesn't truly understand code like a human developer. Instead, it predicts the most likely next token based on patterns it learned during training. When you type a prompt like, create a Python function that sorts a list, the model breaks the text into tokens and predicts the next one, then the next, gradually building the entire function. This happens extremely fast, sometimes generating dozens of tokens every second. In simple terms, AI code generation is a powerful prediction system trained on enormous programming datasets. But the model alone is not enough to write useful code for real projects. If you only give the AI a short prompt, it doesn't know anything about your application, your file structure, or how your code base is organized. This is where the AI-powered IDE comes in. The IDE acts as a bridge between your project and the AI model. When you open a project in tools like Cursor or Windsurf, the editor scans your entire code base, reading file names, imports, functions, classes, and comments to understand how the project is structured. This process is called code indexing. The editor builds an internal map of the code base, identifying files, functions, classes, and the relationships between them using tools like syntax trees, language servers, and code parsers. Once this map exists, the IDE can quickly locate where functionality lives inside the project. Now imagine you give a prompt like, add authentication to this app. The IDE does not send the entire project to the AI model. Real applications may contain thousands or even millions of lines of code, and sending everything would be slow and expensive. Instead, the IDE identifies the most relevant files related to your request. To do this, it uses techniques such as code indexing, dependency graphs, and vector search. The code base is split into smaller chunks and converted into embeddings, numerical representations that capture the meaning of the code, allowing the IDE to search the project by meaning rather than just keywords. When you write a prompt, the IDE searches these embeddings to find code that is semantically related to your request. For example, if you ask for authentication, the system might retrieve files related to routes, user management, and database access. This technique is called Retrieval Augmented Generation, or RAG. Instead of sending the entire project to the model, the IDE selects the most relevant context and sends only those pieces of code. Once the context is selected, the IDE builds a prompt containing your request along with the relevant code snippets and sends it to the AI model. The model then generates code that fits naturally into the existing project. But even after the model generates a response, the IDE still has more work to do. One important thing to understand is that the AI model never directly edits your files. The model only generates instructions describing what should change. For example, it might produce something like a patch or diff, describing which lines should be inserted, removed, or replaced. The IDE then parses this response and maps those changes back to the correct files in the project. Instead of rewriting an entire file, the editor updates only the specific lines that need modification, similar to how version control tools like Git apply changes. Many modern AI IDEs also include a validation loop that checks whether the generated code actually works. The IDE may compile the code, run type checks, or execute tests to see if the changes introduced errors. If something breaks, those error messages can be sent back to the AI model as additional context, and the model generates a fix. This creates a feedback loop where the AI writes code, the IDE tests it, and the system improves the result automatically. And this reveals the real insight behind modern AI coding tools. The AI model, the part that receives most of the attention, is actually the easiest piece to build. The real engineering challenge is everything around it. The systems that understand your codebase, retrieve the right context, safely apply changes, and verify that the software still works. That orchestration layer is what turns a powerful language model into something that feels like an intelligent programming assistant. It also explains why AI coding tools sometimes feel magical and sometimes fail. If the system retrieves the wrong context or misses an important file, the AI can generate incorrect code. But when everything works together, the result feels almost like collaborating with another developer. And that's the real story behind modern AI coding tools. Not just powerful models, but complex systems built around them that allow those models to interact with real software projects. If you're interested in AI, coding, and the future of software development, consider subscribing, and I'll see you in the next video.